Great. What I'm going to go ahead and do is I'm going to start my share. So we have one more talk. That's for me. I'm going to be picking up on this subject of JSON and digging in. Let me go ahead and bring my, go ahead and do a share screen, see if I can get this to come up. All right. You all should be able to see my screen. Yeah, and so I'm just going to kind of pick up where this talk was, where Lorenzo's talk ended, which is just looking at the representation of data, of JSON data in ClickHouse. And what this talk already illustrated is there are so many ways that you can break up JSON and semi-structured data and store it in ClickHouse that it's impossible to do a talk that covers all of them. But what I'm going to do is cover the basics and just, sort of get for people who are learning ClickHouse and would like to understand how to represent basic JSON structures. I hope this will give you a good guideline to what we see as some of the best practices. So name of the talk is Better Than You Think, JSON Data in ClickHouse. And where the title from this came from is we often tend to think of relational databases as storing tables, but of course, over the last decade or so, they have been extended out to cover things like arrays, to cover JSON as a data type. That support is widespread in many other databases. So for example, Postgres has very good JSON support at this point. And so does ClickHouse. So we're going to dig into that. Just a little bit about my background. By the way, can I confirm that my slides are showing? Are you guys able to see them okay?
Yes.
Okay, excellent. Thank you very much. Good. Don't want to go too far if that doesn't work. All right, so I'm Altinity's CEO. I've been working on databases since 1983. I took a few breaks. That's really about 30 years on databases. ClickHouse is number 20, and definitely in my top 2 or 3. The other 2 contenders are Sybase, which was the first relational database that operated on a network. I worked in the connectivity group, among other areas. Really, really innovative and wonderful piece of software that now lives on as Microsoft SQL Server. MySQL is the other one, and had a lot of a database that had a lot of similarities to ClickHouse. I've been a ClickHouse user since 2019. Just a little bit about Altinity. So we are an enterprise provider for ClickHouse. We've been working on ClickHouse since 2017. That's when we were founded. We basically help enterprises use it successfully wherever they want to run it. If you do want us to run ClickHouse for you, we offer Altinity.cloud, which is the first managed ClickHouse in Amazon and now GCP, which was just announced last week. All right, so that's the marketing fluff. The rest of this talk is SQL and a lot of it, except that we're going to start with JSON. So JSON, as you can already see from the previous talk, is pervasive. And this is just a test data set that we use for one of our training classes. It's about 250 million rows of weblogs. They come from, I don't know where they came from, but I think they were all run in 1998, so probably on Apache servers back in the day. And so this is a pretty typical type of record that you will see in JSON. It's basically key value pairs. And in this talk, I'm actually not going to delve very much into complex JSON structures. That's kind of an advanced topic. I'm really going to look at different ways that we can represent, load, and search this type of data. So what you see here is, just 5 values, things like the timestamp, when was the record generated. That's actually a Unix timestamp right there. Client IP, the request, what they were doing, their status, and then the size of the data that was dumped. And when you look at this, representing this in ClickHouse and doing something useful in it, we can divide the representations into ClickHouse into 3 general ways that people approach it. There are many more beyond this, but these are the 3 most common ones. The first is just to take those key value pairs and just map them directly to columns. In this case, you'd have a table with 5 columns. That's good. It has advantages, and we'll start with that first because it's the easiest really going to a native tabular format is really going to give you the best performance and is the simplest to work on. Now, there's another really interesting middle ground, which is to store your JSON in a string. We call it a blob. And then as you need, pull out columns. In other words, materialize certain columns in order to help order the data or to access it more efficiently. This middle ground is actually very, very common. There's a number of very large systems that have used similar approaches, and we'll talk about this in some detail. The final way to represent it is that's quite commonly used is to use pairs of arrays. And so basically those key value pairs, you would split them up and you'd have one array that holds the keys and another array that holds the values. There are variations on this, for example, using the map data type. I'll show you that as well. You can do this in other ways as well. So for example, what we just saw, the time series data and the notion of having different attributes and then having values for them in two different tables, that is another way of representing values that might originally have started out in JSON. So, but we'll stick with these kind of generic ways, and then you can build your own variations on it. So, and by the way, feel free to ask questions. I can see the chat. If it's something relevant, I'll jump in. So here's the bone simple, sort of make it easy on yourself. If you just have fixed records and all you want to do, you're never going to change, and the data type is never going to change. There's a pretty good chance you can just create a table which has exactly these column names. And I'm sort of doubling down on this and even including the @ sign in the in the value, in the column name. You'll see why I do this in a second. But we just type them correctly, and we put them in a merge tree table. And then we have a merge tree, as you probably all know, is the workhorse table for ClickHouse. And then you give merge tree some required parameters. Specifically, how are you going to partition it? So how are you going to break up the table into parts? And in this particular case, we're going to partition by day. So we're going to use to start a day, and then we're going to order by that same timestamp. So within each part, they're going to be ordered. They're going to be in time order. The settings index granularity, that actually happens to be a default value, so you can include that or not as you wish. So this is your simple table, just a direct mapping. And what's kind of cool about ClickHouse is if you just want to jam the data in there, it actually turns out you may be able to read it in just one line. So here's an example of what that data might look like if you get it in, if you're getting it in as JSON data. This is what we call a JSON each row format, where every row has a record, and that record is a standalone JSON document. So it's exactly the data we just looked at a second ago, but no longer formatted. So it's just in one row. And ClickHouse can read this directly. So we just run the ClickHouse client. That's the tool you typically use. You can also push it up through the HTTP interface using curl, or build a Node application, or use Python. There's lots of ways to load it. This is the simplest one. But this basically will load that data in a single command. So you're just telling, insert to ClickHouse client, you're giving ClickHouse client this query, and you're saying, hey, I'm going to insert this, and here's the format the data is in. And then ClickHouse's client is smart enough that it will parse this, figure out what you mean. It does it locally, and then it will just read in from standard IO what's whatever data you have until it's exhausted, and it'll send it up to ClickHouse, and that's that. And as a result, you get this data loaded into the table with virtually no effort whatsoever. You can also do similar things. You could load this data through Kafka using Kafka Table Engine, but the point is that in this basic case, ingesting JSON and turning it into a table can be very simple. The problem is that JSON tends to be usually a little bit more complicated. And here's, without even considering complex JSON structures, there's at least 3 things that can go wrong that would make this more difficult. So one is you just don't know what the columns are up front. That could be for a variety of reasons. Maybe there's a lot of them, maybe they change, maybe, like in time series, it's common for measurements to sometimes have some measurements but not others, in each record. So you wouldn't be able to define the table because you wouldn't know what the columns were. And if there isn't a column for the values to jump into, they're going to be lost or worse still, cause errors. Well, actually, both of these are bad. Here's another problem, which is that the keys and values could just be different between records. Here's a simple example. Imagine that you're managing data out in Amazon, and you have VMs and they're tagged. Well, depending on what they're doing, they'll have a different set of tags. So that's an example of where the tags that you get in your JSON records could actually then need to map to different columns. A final thing is that, real data tends to be dirty, or it may require complex transformations. In either case, you can't just put it into input and expect ClickHouse to figure out what to do with it. So, for example, what do you do about dates that are bad? That's something where you can actually have to give ClickHouse some guidance on what to do with them. So the question is, how do you handle that? Well, the simplest way is to go to the second model, and what you can do is just load the data and store with a minimal amount of header information. So this is an example of a very minimal ETL table where all we're doing is telling where we got the data from. So if we can't figure out what's going on, we can at least go look at the file. And then we have a what we call a blob. So this is just a record that contains a JSON document. And in this case, we're going to store it in merge tree, but we're going to partition by file. That just means that we can drop these parts later. And we're not going to have any ordering because there's not really anything to order on. So order by tuple is a ClickHouse idiom that means don't sort it. Just whatever order you find it, throw it in the part. And so this is what we're going to start with. And in fact, if you do this, you can then, if I can get this to advance, you can load any JSON data. It doesn't matter what the messages are. This is an example of that data in CSV format. It looks pretty awful, but it's whatever's easiest for you to load. It has CSV, and the first element in each line or the first thing in each line is the name of the file, and the next one is the JSON document with some quoting so that we don't lose the quotes. So this you can actually read, and so it doesn't matter what's in the JSON or even whether it's valid or not. It's going to get loaded up into ClickHouse, and then you can decide what to do with it. So this is your starting point. And so I'm just giving this example. You can load it whatever way is easiest for you, but the point is get it into that table. And then when you're there, this is actually kind of cool. Without doing anything else, you can actually start to explore the data. So here are some examples. There's a family of functions called JSON Extract, and these will allow you to grab pieces of data out of the JSON document. So for example, there's a request field in there, a request key. This says, hey, get me the first three, read the first three JSON values you can find and get me the value of request, or nothing if it's not there. So, or similarly, and so it's typed, it comes out as a string, or I could ask for the status, the HTTP status, read the first three records you can find and get me the status typed as an int. And in fact, because these are now coming back and are just ordinary SQL values, you can write real queries with them. So here you have an example where we're pulling out the status and turning it into a thing called status. We're counting them, dropping down to the end. What we're doing is basically grouping these records by status, and we're and ordering. So we're going to get a counts of the different HTTP status codes where they're above 400. And here we're going to go ahead and limit the time to just look at it for a single day. So this is a really this is real. We didn't have to set up any additional schema. We don't have to have any knowledge about sort of knowledge beforehand about what's in there. We just, if we can use these functions, we can answer real questions. The problem is that this query has two issues. One is that it's ugly. And so there's a lot of ways that you could make mistakes here. And real queries, I'm using very simple ones for the purposes of this, but real queries tend to look a little bit more like some of the JSON that you were seeing in the previous talk, or that you may see in your own applications. It's complex and gnarly, and you may have to do a bunch of transformations. The second thing is this is really slow, and we'll talk about that, just how slow, in a minute. So, but before we do that, and we're going to solve both those problems, but before we do that, I want to just point out that these JSON extract functions, there's actually two families of functions that you can use to extract JSON. One's called the JSON Extract family, and there's at least 24, I think something like 24 calls. They can do everything from extracting single values to walking down paths to extracting keys and values together as tuples. They're quite complete. So they do a lot of stuff. Now, they do a complete parse of the JSON object, or at least as much as they need to read the values out. There is another family, so they're slow but very thorough, or slower but more thorough. There is another family called visit param functions, and these are what you might call fast but half-hearted. They do something more like a regex, where they're searching for values, and if they will, under certain circumstances, if things are nested, they may not be able to tell the difference between a value at, like a key at one level, like A, or HTTP or status, something like that. If it's at different levels, they won't necessarily fetch out the right one, but they are very fast. So you can use those. I don't use them very much, but if you did have a performance issue, you could try them out. So getting back to this blob, now we can improve this table significantly in a couple of different ways. The first thing is we want to order the data, and that's pretty important, because if we're storing data, time series data, for example, we need to have we need to be able to see the time. And in most applications, you tend to want to have the parts, that is to say that the sections of the table that are created, be based on time. So for example, one thing we can do is we can go ahead and create a new version of this table, and we're going to create add a field called timestamp. So it still has the blob, the message thing. It has a field called timestamp, and it defaults to a value that just gets sucked out of the blob when it's loaded. And so what this means is then, because we have this timestamp, we can now use that to partition the data properly. In this case, I'm going to partition by the start of month, and I'm going to order by, so I'm going to basically have parts that are divided by month, and within those parts, they're ordered by timestamp. If I wanted to order by more stuff, of course, I'd have to pull those values out so they could be used here. I can actually use the technically, I don't have to, I don't have to pull the columns out technically, but it's more useful. It's going to be more useful, and the queries will be more efficient if ClickHouse can actually see the columns that are being used. And then I can load the data in, and it's really simple. So I have my sort of staging table, if you will, and now all I have to do is pull from that staging table. So I'm going to insert into this new table, and I'm just going to select the file and message values out of HTTP logs. And when they load, they will automatically adopt this new format, and now I'll have the table properly ordered. There's not really a way you can't do this on the table, like the HTTP logs once it's, once it already exists, because you can't change the partitioning and you can't change the sort order. Other than unless you're adding columns. So you can't really do this transformation on the original table. So we have to make a new table and then copy the data in. The other thing we can do, and this is a really cool ClickHouse feature, is we can add columns. And I could have defined this up front, but the point that I wanted to illustrate here is that with ClickHouse, you can start with that, with this sorted table where, I make a basic decision. Okay, I'm going to sort it by time. That's pretty easy to make. And then as I need it, I can add columns to this table. And here's an example. I'm going to add a column called status. And what it's going to do is it's going to have an int16 type, so it's big enough to hold this status code, and it's going to have a default value. And what it's going to do here is it's going to suck out the grab that status value, convert it to an int. It's also going to do something really important, which is it's going to add a codec here, a codec clause. And what this does is it changes the compression. So, oops, can you guys hear me okay? I'm having looks like my computer is misbehaving.
Yes.
Voice is okay?
Yeah, it's okay.
Sounds great.
Okay, great. Thanks. I'm getting a Windows message about low system resources. Got to kill some Chrome browsers off. All right, I'll keep going. So this is a really powerful feature. And if you run this command, if you're familiar with this, you run this command and it completes instantly. This is a data set that actually has 30 million rows in it. But this returns instantly. And the reason is it's a metadata change. At that point, it's as if this new column existed. Now, for us to get real benefits from it, and what'll happen is if you do a select off it, ClickHouse will just run this default expression to go fetch the value. So it's a virtual column at this point, you might say. What we can do is we can add other columns and then we can force them to be materialized. The traditional way to do this, over the last couple of years, is just to do an alter table and then you do an update, and this is the way that we do it: set status equal to status, request equal to request, where one. What this will do is it will rewrite all the existing parts, and only rewrite the columns that need to be materialized. So it's pretty efficient. It does this asynchronously. That's what alter table does. So what you'll get is what's called a mutation. This will go back. It'll appear in system.mutations. And at some point in the future, hopefully not too far, you will actually have this data fully materialized. At that point, life gets good. So the query is way simpler. So we've got first of all, we can deal with something that looks more like, real SQL, just status, group by status, no complex, no necessity for complex functions. Moreover, that's not the most, simplicity, hey, we're all programmers, we can deal with stuff that's complicated, but this is obviously good. What's better though, and more important for many applications, is it's way faster. So this was 30 million rows that I was just playing around with, and I actually have a bigger data set, but I was just using something small. But this query now runs, the original query I showed ran in 9.8 seconds, which is, for ClickHouse, is way slow for 30 million rows. This runs in 14 milliseconds. So it's about 700, I ran the math quickly, and it's about 700 times faster. And what's going on here is that this status is going to be vastly smaller, and I'll prove that to you in just a minute. So there's like 100x less, so we're going to scan all these status values. There's going to be 100x less, fewer bytes to read. The other thing is we can also use the primary key index here, and we can recognize that, hey, we're only looking for a day, so we're going to drop everything that isn't part of that day, and so we can take advantage of the primary key index. So as a result, this is now what we call ClickHouse Fast, and this is one of the reasons why you can store stuff in JSON, but one of the reasons why you want to actually pull these columns out is you can think of them as almost being like indexes that you're giving new pathways that are easier to use and vastly faster to access your data. And in fact, if we want to dig into why is it fast and just prove that statement about the amount of I/O, if you look at what I have right here, is I've gone and collected the sizes of each of these columns and graphed them out. So these blue bars are the number of bytes that are stored for each column in this 30 million row data set. And so, for example, the messages are pretty big. They're like 1.6 gigs of data. That means that to answer that first query, ClickHouse had to scan 1.6 gigs. It's not fast. That's, yeah, it's compressed, but yeah, it can parallelize, but it's just scanning a lot more data. If we have status out, then, and we're really asking a question about that, that is, and you can just run the numbers here, that's about 15 megs. Moreover, that 15 megs is, you know, so that's just like that's like 100 times less data that you have to look at. So you can also see some kind of interesting effects here. Now, one thing that's kind of interesting to look at is that this is the levels of compression. JSON does not take up that much space. It compresses extremely efficiently. So this right-hand side does show you what the compression levels are, and the blobs are compressing at about here probably about 85%. I don't have the number in front of me, but it's something like that. So they're pretty good. The timestamp is compressing at 100%. And I'm just curious if I'll let you guys think about why that is. This is tiny. This is like an almost incomprehensibly small amount of data compared to anything else here. It doesn't even show as a bar. Give you guys like 2 seconds to think about this. Okay, let's go back to the table definition. Here we go. So the timestamp is going to be really small because we're ordering by, we're partitioning by the start of month, and then we're ordering by the timestamp. So you're going to have a bunch of timestamps that are overlapping. And in fact, what I can do is I can apply an additional codec to this. I could make this even smaller probably by applying a delta codec. So all it would do is store the differences between timestamps, but there's basically going to be a lot of repetition in this data. So because they're values there's strings of bits where there's just a small amount of variation, if at all, between succeeding values. So that's an example of how, again, how getting the data properly ordered is going to give you a big boost in performance as well as storage. Okay, so, and speaking of indexes, I don't do this in this example, but you can go ahead, once the columns are out, you can then go ahead and apply additional indexes to them. We were talking about Bloom filters in the previous talk. That's an index you can do for things like timestamp or status. You can do, min-max indexes, look for, these are particularly useful for finding outliers. And then there's other indexes as well. So there's just a bunch of ways that you can goose up performance, and this will give you really outstanding performance. By the way, column data sizes are really important. So here's how we got it. This is, I'm not going to read the query, but it's in here in the slides. You can steal it if you want. I tend to run this pretty regularly just to see how things are going on storage. Let's look at a couple other ways to hold these JSON values. Maps. So a map is just key value pairs. You can think of it as like a set of tuples, basically. Here's an example. So we're going to create HTTP logs map. Oh, here I was using my, I was getting more excited about date time and actually putting the delta codec in, and putting ZSTD compression. I put that in because it's good for compressing integer values. So what we have here then is just this map where it's going to map strings to strings, and that will be, the first one will be the key, the second one will be the value. Otherwise, it's pretty similar to what we had before. Loading this is fairly straightforward. We can actually copy from our base table, and as we select the file, in order to load it into the message, what we're going to do is to load it into the map. We're going to use this JSON extract keys and values. That's a really handy function. It goes down your JSON, and every key and every value is put together in a tuple. So you basically get an array of these guys, and then they just jump right into the map, and that's all you have to do. So this kind of loading is fairly simple as long as your data is not too messed up. And then what you can do is maps are very easy to use. They kind of look like hash tables. In fact, that's basically the syntax. So if I want to get the status out and do that group by, I can, just here's how I reference the value. And this query is about 4 or 5. It's not 700 times faster, but it's 4 or 5 times faster than going to the native to the JSON blob. And the reason is the map is just more efficient at getting to the place where the value is stored and pulling it out. So this is just using a map is already a pretty big difference. There's a final transformation or sort of representation I like to talk about, which is the paired arrays, which I mentioned at the beginning. These are similar to, similar idea to maps, sort of key value pairs. But in this case, what we'll have is 2 arrays. ClickHouse has very, very good array support. If you're not familiar with it, it's one of the really interesting extensions. But we have an array of keys. These are strings, values that are strings. We could go, if the measurements were in fact, if we're doing time series and the measurements are in fact all numerical, or that happens to be the application, we could also have these done as floats or something like that, or we could have different there's a bunch of variations on this, but this is the simplest one. And again, timestamp to get the ordering and using the codec, the delta codec plus the STD. So if we do this, when we load, let's see, did I show the loading of the data? Oh, I didn't show the loading, but I'll show it a little later. I think I dropped it off. The loading is more complicated. I'll show you how we did that in a minute. But assuming we load it, and there's going to be an interesting transformation to get that, what we're going to do is we can go ahead and use array functions, of which ClickHouse has a vast library, and to find the to find the status values, what we're going to have to do is dereference, find the index of the key or the status key. So that's like 3. And then we have to read that value out of values. And that's how we get this, these results. And I didn't include them on the map example because there's not enough room, but it's exactly the same results as we got with the map. And again, it's about 4 to 5 times faster, over 30 million rows in this particular setup, for the same reason that we're not having to read the whole JSON object, but instead doing a quick search, finding the value and reading that. So a question about paired arrays, just to make crystal clear what this really looks like in reality, is if we load it properly, we get keys and we get values, and they're basically just 2 arrays where there's a 1-to-1 match. So if you find the request, for example, you're going to, that's key number 3 actually, status is 4. In this example, it will exactly match to the 4th value. And I'll show you how to get these out of the JSON so that they match up. Okay, so these are the, oh, here we go. Here's the example of loading. I had the slides out of order. So it's a little bit more complicated. It's using what's called an array map function. And basically what we're doing is we're using JSON extract keys and values. This pulls the data out as an array of tuples where each key is matched to each value. And so we do 2 map operations, one where we read through those tuples and we pull the first value out and that goes into the keys, and another map operation where we pull the second value out and that goes into the values. If you've if you've used arrays before, this is not unfamiliar to you. If you haven't, then it's probably kind of a shock to the system and something that is best hidden in your ETL pipeline, so that you don't have to think about it too much. So that's basically how we load it. The key thing though is ClickHouse can just do this transformation internally without any extra help. So question here, which is sort of the final topic on JSON, is, well, we've been talking a lot about copying, to achieve these different representations. We have like like a buffer table or a staging table, if you will, and then we copy to where it really belongs by doing that insert from select. This is kind of painful. So the question is, in a real system, would you do it this way? And the answer is no. Here's what most people do. They use materialized views. So you can actually, and I even said this in a previous comment, you can actually do this stuff outside in your ETL pipeline. But if you're going to just throw the data into ClickHouse, you might as well just do the transformation there, because ClickHouse is very fast. So what we're going to do is insert into a table for ETL. We're going to call it our ETL table. And then we're going to create a materialized view on that table that every time a block is, and the way materialized views work is every time a block is inserted into the first table, the materialized view runs a select on it, and whatever it finds, it sticks in a second table. So, so this allows, and the materialized view can then take care of the transformation. So here's how it works. So we're going to create the base ETL table, and it looks just like the original table we had, except for one, the blob table, except for one important thing. We're going to use what's called a null table engine. And this is kind of a cool trick. It is a table engine in ClickHouse that has no storage. And the reason is we really don't want to store the data in this form. We just want to see it and have it around and allow the data to be inserted and have the trigger fire. In other words, the materialized view should fire and do the conversion and put the data in the right place. But we don't want to store the data. And the null table engine does exactly that. That's one of the main uses for it. So we set this up. And then the next thing is we're just going to create the target table exactly as we did before. So this is no different from the version I set up previously. What we've added is the materialized view. So this is a materialized view, and a materialized view is like an insert trigger, fires on every block that gets inserted. You have a target table that's in this to clause, so where we're going to, and then what is the transform that you're going to run on the data when that block is loaded. And this is very flexible. You can do any transforms you like. So I put this in. This is a good candidate because these are, sort of complex transforms. I've seen examples of this for users where they were far more complicated than that. They sometimes, like transforming, like 100 columns or something like that. But this is great. You hide it inside the materialized view. And then you can also join on other tables. So if you need to pull data in, you can actually have joins where you suck out, sort of reference values. That can be included, or you can put filter conditions in, like where conditions. So you could even have these be selective and say, hey, I only want data that has a certain format. So this is a common model that we see is people will actually have multiple JSON data types that get loaded into the same staging table, and then have a bunch of materialized views that are triggered off those tables, and then each view chooses the data that it wants and does the correct transformation and sticks it in the right table type. So it's a very flexible way of doing ETL, and just really removes a lot of it can remove pipelines almost completely. And the load is pretty simple. Here's just an example that I ran to confirm that I hadn't screwed it up. I'll truncate my arrays table, and what I'll do is I'll now insert data, and this I could insert it from outside, or in this case, I'm copying it in just to simulate it. I'm going to go ahead and insert into this table, and then I'm going to go ahead and do a select count off the target table, and what I see is I get exactly 1 million rows immediately after. And this is another cool feature about ClickHouse. I think everybody here is aware of this, but materialized views are synchronous. So as soon as your application, generally speaking, as soon as your application gets a response back, the materialized view is already fired and the data is sitting happily in its new home. This is it. So it's supposed to be, I've run a little over time, but let me just finish with some roadmap information. So ClickHouse JSON support there's a lot of stuff you can do in ClickHouse, but it does require programming skills. I think a couple of things though that are just, these JSON functions they're hard. This is kind of an inefficient example. There's actually a better way of doing this, but you can often find, you'll get these functions sort of stacked one on top of another as you fish data out of complex structures. So that's the access is difficult. It's easy to make mistakes. And of course, when things change, you then have to go in and figure out exactly you were doing and get it to work. The other thing, as I illustrated, was the performance is hard to optimize. So you actually have to have human beings making decisions about, codecs, specific, compression formats, maybe adding indexes, deciding which columns to pull out. These are all things where ClickHouse doesn't give you any help. You have to do it yourself, and you have to know what you're doing. The good news is there's a major feature on the way called semi-structured data. This is going to be one of the big, probably one of the biggest features added this year. And basically what ClickHouse will do is that blob that I showed you will get mapped automatically to a structure with columnar storage. And it will also provide convenient query syntax. So like if you have, instead of this example here where we're going to A to B to C, you'll be able to select A.B.C. Out of the nested. It will basically map it into a nested data structure. So between these two things, the ClickHouse performance will on JSON data will almost certainly become considerably better in most, if not all, use cases. The other thing is that you'll just be able to write queries that are easier to understand, and there'll be less necessity to pull things out and to deal with, sort of complex operations to get the data you want. So I think that's going to be a huge improvement. What we see right here, this issue is actually the 2021 roadmap from Alexei, and it describes the PRs that are going into the support for semi-structured data. This is a great feature, and one that has been an ask for years at this point. In the meantime, people are building big systems that ingest JSON, not Java. Here's just options. I covered 4 of them. I think the winner tends to be store the JSON blob and then pull, then add columns with suitable indexes or compression as you need. That's definitely the fan favorite. There's a bunch of systems that have used something like this to deal with multiple, for example, service logs to deal with multiple log types. And then you can use the materialized views as a way of transforming them. That's also a very, very common pattern. And then, of course, ClickHouse has many other features. You can split things into multiple tables. You can just mix and match other ClickHouse features to just process your JSON in the way that works the best way for your app. So there's no reason to wait for semi-structured data. This stuff already works really well, and you can build very, very high performance systems. So we've seen many examples of those. So that's it. I'm open for questions. Just we're Altinity, so come talk to us if you want to hear more about this. This is ClickHouse, great piece of software. And then a little bit about Altinity.cloud. And one final thing, if you think this stuff was easy and that you could do it better than I did, we want to talk to you. We're hiring like mad. So with that, any questions? Let me see if we've got let's see. Okay, great. Question about inserting extraction will omit, let's see. I wonder if this is a question from Vlad. Question about inserting extraction will omit non-strings. How do you deal with it? I'm not sure if it, okay. Assuming that was this is a question coming off YouTube, assuming that's a question about JSON, there are a bunch of cases where insertion will fail or not get the data. A really common problem is dates. So this is one of the reasons why you can't just read dates out of CSV. A lot of times because you need to, there's I just lost my track. There is a nice function that is kind of like a best effort attempt to parse dates in ISO, date times in ISO format, and it will do the best it can, or otherwise it'll throw up its hands and give you a null, as opposed to just failing or doing something awful. So so this is why these transformations tend to be kind of complicated, and why you really have to, there's really some thought required in how you do them. Beyond that, Yeah, put it in the materialized views are a good place to do this because it does allow you to put this transformation logic in one place and do it once on ingest. And if you don't like what you did, you can just, wipe the data out and re-ingest it. So, that's sort of, I think, how a lot of people deal with. Is there an update of when semi-structured data may land? Actually, this year. Alexander, I don't know if you're familiar with it. There's about 6 or 8 PRs listed in Alexi's doc. I don't know what the status is. I believe some of the features are in. Actually, I know because I've seen this work, but only in somebody's fork. The full support is still not merged.
Which one?
This is semi-structured data.
Yeah, I think it's still in progress, but it should be completed soon.
Yeah, next month or two, something like that.
Before end of year.
Before end of year, it will be experimental for some time. But you'll be able to actually see it in a ClickHouse build, I would guess, by the end of the year for sure. We've got over 2 months. Where can I find more information about the codec tricks you spoke about? Let me think. Public stuff. So we do a lot of talks on this, so you can find it. So you can find them in Altinity webinars. You can find them in the ClickHouse documentation. But one of the things that ClickHouse docs don't do is they don't really tell you how to manage this. This is also something that we cover in detail in our ClickHouse 101 class, which is a commercial class. But we spend a fair amount of time on codecs. I think the really key thing about codecs, one of the things that makes codecs actually kind of manageable, is that ClickHouse has really, really good, here we go. New encodings, thank you, Alexander. New encodings to improve ClickHouse. Yeah, this is a blog that was done by Vasily Nemkov, who implemented a couple of the more recent ones. One of the things you want to do is get really familiar with the system.columns table. That is how you can tell how much compression you've got and what codecs are currently being applied. Using that table, then it's usually pretty simple to figure out which codecs. And then any talk I've done on ClickHouse performance, I haven't done one this year, but I had one last year that talks about this in some depth as well. Codecs and sort orders, codecs compression and sort orders, they're all closely related. Let's see. I don't see any other questions in this talk. So we have time to the top of the hour. I'd like to open this up. If anybody has any questions about ClickHouse in general, please feel free to shout out, and we or other people in the here will be happy to answer them. So, and if you want to speak up, go ahead and let us know in the chat or raise your hand and I'll unmute you. So we're open for questions.
Great presentation, by the way, as always.
Thanks, Lorenzo. Yeah, we've had a bunch of nice talks over the years. Thank you so much for the for your talk on C-Loki. That's great. I've seen it before, but this is it gets better every time. So let's see. I'm not seeing any questions coming up. We had an answered one. Yeah, looks like. Well, is there any other topics people would like to open up about? Sort of things they'd like to share about ClickHouse. I'm happy to unmute people, and we can. In fact, I'll just go ahead. Oops, I'm going to go ahead and unmute. And so anybody who'd like to speak up, feel free to do so. All right. Okay, I don't see anything off. Don't see anything coming off YouTube. So if we don't have any further questions, it's for those of us living in California the way I am, it's time for lunch. So thank you so much. I want to give a huge shout out to Joaquin and to Lorenzo for great talks. I'd also like to give thanks to Alexander Zaitsev as well as Alexei Milovidov for comments on the on the presentation on JSON. Thank you both very much. It's really helpful.
Yeah,
All right. Go ahead, Geek. Go
I
for
have
it.
a last moment
Yeah.
question for Lorenzo, because I remember that I saw them that they are going to work on the live views. So if they are working on the live views on Node.js, if they need to work out using Node.js, I'm available to also work with them and do something about that, because I know that it can be a little bit complex when you're using Node.js to get the live views information. So only that.
Absolutely. That's thank you so very much. Absolutely. Let's get in touch with each other, and this is why we do open source, is to
this is why we do meetups,
to work with other smart people, on complex issues. That's how good things happen. So thank you so much.
Okay,
definitely.
I'm post personalization. I love both. So
I want to say. Oh, sorry. I keep getting confused about the latency. I just had a question pop up. Is this talk going to be posted online? All of them. So we will. We're recording on. We're going out to YouTube right now. That live stream will be posted automatically. I'm also doing a Zoom recording of Joaquin's, Lorenzo's, and my own talk. I will cut them into pieces, post them. Joaquin and Lorenzo, if I could request, please shoot me a PDF of your slides. I'll get them posted, and I'll also give you links. We'll do a short blog article as well. Keep an eye out, and we'll just give everybody the links to that. So wonderful. Great. Any other things that people would like to bring up before we close up? All right, going once, twice, 3 times. Thank you, everybody. Thank you to our audience, and we'll see you at the next meetup. We're going to do one in December. If you got something you want to talk about, let me know, and we'll get you on the schedule. Thank you very much.
Thank you.
All right. Bye, everybody.